đầm đời muốn đỡ lại tia thì kết hệ như thế
Отлично, убит.
Okay, yesterday we completed the Wi-Fi up to Wi-Fi. Let's continue today client server method of connecting computer. First, let's discuss about the client server network. Client server network is a system where one or more computers, okay, one or more computers or one or more network enabled devices, you can say, connected together. So one is the server and one is the client. In the client server architectures, client send the request to the server and server reply the request to the client. That is communicate and it share the resources of the server to the clients. So its client computers must use an operating system that allows it to be defined to be participate in the network. It's having a special operating system to serve the purpose of their client request. So we need a special operating system for the server to participate in the network. Okay, this is the example of the client server architectures. Here we have a network, and in between inside this network we are having different types of resources like computer server and printer and scanner, different types of networking equipments. Computers refers to as a client server. At least one of the computers is used to serve other computer refers to as clients. Besides the computers, the types of devices can be a part of the network in the client server architecture. Client server architecture environment. Each computer still hold its resources and file. Other computer can also access the resources stored in the computers. Is a peer-to-peer scenario. One of the particulars of the client server network is that file and resources are centralized. We have a centralized resource management in this client server architectures. This means that the computers, the servers can hold them and others computer can access them. Since the server is always on, the client's machines can access the file, the resources without caring whether a certain computer is on. So it's needed to turn on 24/7 to serve the purpose of this architectures, for this architecture. Okay, one of the consequences of this client server architecture is that if the server is turned off, it resources and sometimes most of the resources of the network are not available. So if it is off, then service gone. The service of the server is off. So you need to turn off 24/7 to give the resources service by the server. In fact, one way to set up a client server network is to move more than one server. In this, each server can play a different role. So this means that we can have a distributed server like Facebook, WhatsApp, and other Instagrams. They have a big server, distributed server. So they have a multiple of server that we cannot experience that server down of the Facebook server down of the Instagram server down of the WhatsApp. So it is the distributed server. So they did not have a problem regarding this. This is a 24 by 7, 365 days uptime. Okay, there is no downtime. Okay, let's move on to the physical structure topology. Physical structure topology, under this we have different types. Number one is the point-to-point link. In this point-to-point link, one computer is connected to these computers. There is no other connectivity. Okay, one-to-one communications, point-to-point. And a multi-point, this means this is the main server, and from this it's connected to the multi-point. So this is called the multi-point connections. And below this we have a physical topology. There are more connectivity links, 2 or more links from a topology, a link device in a network called node. Okay, node connected to this. There are 4 basic types of topology availables. Okay, let's move on to the first one, mesh topology. In this mesh topology, each device has a dedicated point-to-point link to every other devices. In mesh topology, each physical link carries information only between the 2 devices that is connected. If it is a duplex connections, you only need half the physical link, since its links travel both ways. Advantage of this mesh topology is that avoid traffic, since each link can carry its own data and none are being shared. So it has its say suppose if it is 5 computers in the mesh topology, so each and every node having dedicated line. There is no shared line, so it is called a mesh topology. So if one link break and the rest of the network still functions, so if there is breakdown in the connectivity, then all the connections in the peer-to-peer connections, peer-to-peer means one-to-one connections like this, peer-to-peer connections. So there is no link down. If this link is down, and all other links are still up, okay, there is no issue. Okay, these are the things in this mesh topology. Advantages: avoid traffic, since its link can carry its own data and none are being shared. So line are not shared with each other. Okay, if one link breaks, the rest of the network is still functional. So still function the network. Privacy, since only the dedicated devices receive the message. Easy to detect the problem in the network by discovering which device is having problem, the link that connected to it. So it's very easy to detect this one, that each and every system having a dedicated connectivity. So this doesn't having a problems. Disadvantages of this mesh topology is that a lot of cables are needed. That's true. In the mesh topology, we have a lot of cables because of this dedicated connectivity. Too many cables, too much cost. Okay? Too many cables, not enough physical space. That's correct. Each and every cable is having a node-to-node connectivity. Then here n connections is equal to 2. Okay, n is the number of nodes is 1, 2, 3, 4, 5. 5 nodes are there. So how many links is required? Into 2. Okay, into 2 means this is peer-to-peer connections. Okay, peer-to-peer connections. If the number of n is 5, then if you multiply by 2, then here we have a here we have 10 links. So if the node is 25 into 2, how much? So into 2 means peer-to-peer. Okay, peer-to-peer means each and every cable is needed to connect the 2 nodes. Okay, so that's why we have to multiply by 2. Okay, this one. Let's move on to the next point, star topology. This is the very common network. Still, we are using in today's network also, star topology. Each device is connected to a hub through a dedicated point-to-point link. So each device is connected to a point-to-point link from the hub. Hub is the main network server. Okay, main network server device. Okay, server device. So not only hub, switch also there. Switch also a device in the star. Okay, star topology. The devices are not directly connected to each other. It's connected to the switch or the hub. If one device wants to send data to another, it's sent first to the switch or the hub and then forwarded to the data of the other devices. So it's sent, all the data sent via the hub or the switch. Advantage of the star topology: less expensive than mesh, easy to install, easy to configure. If one link fails and the networks can still functions. Okay, one link fails, then network still can functions. But if the main hub down, then all the network downs. That's the problem of the star topology. Disadvantage of the star topology is that everything depend on the hub. Is depend on the hub. Okay, if the hub or the switch down, the main controller down, then the whole network down. Let's move on to the bus topology. Bus means that here we have a bus topology like this. Okay, in the bus topology we are having like this. Here the main trunk line is there. In the main trunk lines, all the devices are tapped to this main trunk line. So at the end of this we have the terminators. Okay, network terminators. So this is the bus topology. Long cables act as a backbone. Okay, in the bus topology we are having the backbone. Other devices are connected to a drop line and a tap in the link. So drop line and tap in the links. So this is the backbone structures. Drop line connections running between a device and main cables. Tap a physical device that puncture the cables and connected to it. So from the main trunk lines, it tap the signals. Okay, it's puncture the signals, so it's connected to the device. The longer the cables, the more tap it has weaker, and the signal becomes weaker. The signals becomes. So if it's more tap, then the signal will become weak. Okay, attenuated. The tap should be a short distance from one another's. Advantages of this bus topology is that easy to install, minimal cables, and the disadvantages is that difficult to reconnections. So if it's already tapped, it's very difficult to retap it. So difficult to find the problems. So if there are some link down, then very difficult to find out. There is no common connections. Here we have only a main trunk line is there. So difficult to add new device. If it's cut down, then it's drop the line between these two computers. If you cut this one, so for tapping is needed to cut the line. So breaking stop all transmission of data. So if there's some break, it's just stop all the transmissions. So at the end, both end we have terminators. Okay, these are the things in this bus topology. Here we have a puncture. Okay, tap puncture. This vampire taps is there. From this vampire tap, here transmitter and receiver is there, and this is the thickness of this cable, and from here it's connected to the devices, computers. So this is very expensive in this. So we are not using for the LAN connections. We are still use the star topology in the LAN connections. Okay, number 4, ring device. Devices in a ring topology that has dedicated point-to-point connections, which only the two devices are either side of it. So this is the ring type, dedicated point-to-point connections in the ring type. A signal is passed along the ring in one direction from the device to device until the destination is reached. So a signal is passed on to each and every device in the ring. Okay. Each device can has repeaters that passes the data received that is intent for other devices along. So let's see here in the graphics. Here we have a ring topology. Okay, in this ring topology, here we have a repeater. Each and every device have repeaters. Then it's forwarded to each and every repeaters. So from the repeaters, the computers access the network. So this ring is implemented in the fiber optics network. This device has a repeater that passes data received that is intended to other device along. And what are the advantages of this ring topology? Easy to install, easy to reconfigure, easy to detect the problems. So if the ring down, if the repeater downs, then that is easy to detect this one. If the repeater downs, then it's reconfigure it, the repeaters. Change the repeater and reconfigure it. And the disadvantages is that break means, well, the system is dead. Okay. Break means the whole system dead. So if the whole system dead, then it's break it down. Okay. Okay. And these are the things comes under this topology. We have to move on to the Open System Connections, OSI. Last class I already explained that what is the OSI. OSI is the layer standard, okay, from transferring the data from source to destinations using the rules and regulations. Without rules and regulations, we cannot transmit the data from one computer to another, or the one device to another, one mobile to another mobile, or tablet to the computers. So using the network, we need standardizations. Standardization means ISO, International Organization Standardizations. This is called the Open Source Interconnections, OSI, reference model. Okay. In this OSI reference model, we have 7 layers. We have 7 layers. Down below, the lowest one is the first. The first layer is the physical layer. Physical connectivity, the hardware connectivity. The physical connectivity is the physical layer, and the second is the data link layer. Data link layer, how it's work, we'll learn it later. And the third one is the network layer. Fourth one is the transport layer. Fifth, session layer, presentation layer, and then the application layer. So the senders start from the application layer. We are having the applications for transferring the data in the social media, WhatsApp, Facebook, Instagram, all these application user interface is the application layer. You can enter, you can post picture, all these things in the application layer. So it goes down to the physical layer, step by step. Physical layer, from this application layer, starting from the sender, let's see. It starts from the application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. In the physical layer, it transmits the data from one source to another, from source to the destinations. But at the end, it starts from the physical layer. It reverses. It starts from the layer 1, physical layer. It receives the data from the physical layer. It goes to the data link layer, network layer, transport layer, session layer, presentation layer, and application layer. Up to this, then you can receive your data at the destination. So okay, see, these are the things that comes under this network. Let's see what is the physical layers. The lower layer of the OSI reference model in this physical layer is responsible for the actual physical connections between the devices. Very clear. Actual connections, physically connections. The physical layer contains information in the form of bits. It's clear, 010101. It transmits in the form of bits in the physical layer. It is responsible for transmitting individual bits from one node to the next. When receiving data, this layer will get the signals received and convert it into the 0s and 1 and send them to the data link layers, which will put the frame together. So all these physical layers receive the informations in the form of zeros and one only. There is no other things. And the physical connectivity like cable, wireless, or anything by any means. Okay, transmission media by any means. This is the physical. Okay, it's transfer those information in the form of zeros and one. Okay, zeros and one signals from source to the destination. Signals are transferred from the source to the destinations. Then the functions of the physical layer are bit synchronizations is need to synchronize the clock from the source to destinations, sent and received. So we need a synchronized clock from the source to destinations to send and receive the data. This could control both the send and receiver, thus providing synchronization bit synchronization at the bit level. So we need to have a same clock synchronizations to send and receive the data from the source to destination. So bit rate control. Physical layer also define the transmission rate, the number of bits sent per second, how many bits we can send per minute or per second or per hours. So the rates should be controlled by the physical layers. So those functions are very important. Number one is the bit synchronizations, clock control, source and the destinations, and number two is the bit rate control, how many bit we can transfer in the seconds or in a minute or in an hour. So the next one is the physical topology. So physical topology, we already explained that the topology of the network. So how we are going to connect the physical devices using the star or mesh or bus or anything. So this is identified by the physical layer. And then the second one is the transmission mode. What are the transmission mode of transmissions? Whether in the single connections, single or one-way communications, or two-way communications, or full duplex communications. So this should be identified by the physical layers, the flow of the flow of data. So under this transition mode, we have three transition mode here: simplex, half duplex, and full duplex. What is the simplex? Simplex means one-way communications from source to destinations. Destinations cannot communicate back to the source. Okay, this one-way communications. Today we are having the TV. Cable TV cannot talk back to the cable operators. Okay, we can receive the signals, then we can display it in our TV using through the set-top box. So this is the techniques of the simplex. Okay, one-way communications, only one way. The second one is the half duplex. Half duplex means what? Half duplex means both way communication, but not at the same time. Say suppose if we are having the walkie-talkie, then in the walkie-talkie that the senders send by pressing the button. Okay, by pressing the buttons it's talk. Then after its talk is over, then it's say over, then it's release the buttons. Then another party press the button and it can talk, but they cannot talk at the same time. So this is called the both-way communication. Both-way communications, but not at the same time. This is called the half duplex. And full duplex means what? Communications both directions, but at the same time. In a telephone communication also, in our mobile phone communications, if you dial your friend's numbers, then you speak up, then you can talk together at the same time. So this is the both-way communication. Our network, computer network, also our internet connections, fiber optic communications, all those things comes under this internet connections also. The full duplex. Okay. Your SMS also is full duplex. While sending the message from one location to another in a WhatsApp also, you can receive the message. There is no issue. It does not hamper, it does not control the receiving side while you transmitting the data. So these are the three types of the transmission board. Okay, I thought it's clear this one, and it's come under this these things: hub repeaters, modem cables are the physical layer devices. Okay, physical layer devices are the hub repeaters, modem, routers. All those things comes under these physical devices. Okay, physical layer devices. And network layer, data link layer, physical layer, also known as lower layer or the hardware layer. We can say that this hardware control layer. Okay, hardware control layer. And here number two, layer number two, the lower one, layer number one is the physical layer, and number two is the data link layers. Okay, data link layer, DLL, now layer number two. You have to know the number of layer. Layer number one is the physical layer, number two is the data link layer. Okay, data link layer is responsible for the node to node delivery of the message. So that's very clear. In our physical layer, it's maintain only the binary informations, bit by bit, bit synchronization, and then the bit per seconds, how many bits we can transmit in the seconds or in a minute or in an hours. So synchronizations, bit transmissions, and other things, physical topology, transmission mode, all these things are in the physical layer. But we did not have the complete message, how it structured those binary 010101, all these things we have to restructure it in the original forms. So data link layer is responsible to the node to node delivery. So from node to node means from one computer to another, another's delivery of the message. Okay, the main functions of this layer is to make sure data transfer or error free from node to node, from one node to another node over the physical layer. So this is one of the function of the data link layer, error free transmissions without error. The responsibility of the physical layer is to transmit the binary value 01001, only this. But data link layer is the responsible for delivering the message from one node to another without error. Okay, error free over the physical layer. When a packet arrives in a network, it is responsibility of the in the network, it is responsibility of the data link layer to transmit it to the host using the MAC address. So MAC address, I already explained that. MAC address is the source of address to transmit the data from one location to another. So how we are going to identify that the source computer and the destination computers, multiple million, billion, or 20 numbers or 100 numbers of computers. So whatever, doesn't matter the number of computer in the network, but we have to identify the computers. This will be identified by the MAC address. Okay, so MAC address is very, very important in the data link layer. Using this MAC address, it transmits the data from the source to the destination. Okay, so let's move on to the next point. Data link layer divided into two sub layers. So number one is the logical link control, LLC, and media access control MAC address. So packet arrived from the network is further divided into frame. So divided into a frame. From the network layer to the data link layer, it's divided into a frame. So if we say a frame, this is called the data link layer, not in the network layer. Okay, frames means in the data link layer, not in the network layer. So it's divided into a frame depending on the frame size of the network interface card. So it's every computer, tablet, mobile phones, all those networking devices like a smart TV having the network interface card. All those network enabled devices having the network interface card. So this divided into a frame depending on the frame size of the NIC, network interface card. Those frame sizes depend on the frame size of the network interface card of the devices. Maybe a smart TV, or maybe a mobile phone, or maybe a computer, or maybe a server. So it depends on this. the frame size is divided. Okay, so data link layer are also encapsulate send and receiver MAC address in the headers. So each and every transmissions we have a sender and receiver headers that this will encapsulate inside this. It's added up. Encapsulations means it's added up the MAC address. Okay, each and every frame is added up the MAC address in the headers. So header information is very important. The receiver's MAC address is obtained by placing the ARP, address resolution protocol ARP request onto the where asking who has the IP address, and the destination's host will reply with its MAC address. So ARP, in the ARP request, we'll learn it later on this one, we know our MAC address, but we don't know the IP address. So who is having this? Who is having the IP address? Who has that IP address of this? Okay, for this MAC address. So this request is called the address resolution protocol. We'll learn it later. This is MAC address obtaining from the ARP. Those MAC address obtained from the ARP. We'll learn later that how it's working of this ARP. Function of the data link layer. Number one is framing. Okay, this framing is done from the data received from the network layers. Okay, it's framed based on the frame size of the network interface card. Okay, network NIC. It provides a way to send or to transmit the set of bits that are meaningful to the receivers. This can be accomplished by attaching special bits to the beginning and the end of the frame. So we have a header and a trailer in each and every frame. Okay, maybe the MAC address or the frame size or anything. This is done by the data link layer framing. Okay, and then the number two is the physical addressings. What is the physical addressings? Physical addressings means this MAC address. Okay, MAC address of the sender and receivers. This is physical addressings. This is also the function of the data link layer to know the physical address of the sender and receivers. So using this, it's added in the frame header to transmit to the network without knowing the information's address. Okay, without knowing the address. Okay, let me give you one hint. You ordered the one item from Amazon, then you have to go to buy and you have to add your complete address. Without knowing this complete address, how they will send the item, that's very clear. But in the address, you can not simply write Moana or Moi in the name only without any other additional. There's lots of Moana and Moi in Mizoram, in Aizawl also. So you have to give the specific address, right? Your name, your locations, and your phone numbers, your PIN code, your locality. Okay, all these things is your address. Then they can pick up your complete delivery from Amazon. Okay, so you have to give your complete address. Like this, my computer also needed to send out to the multiple million of routers in the internet. So million and trillions of computers are interconnected in the network. So how they know my computers or my mobile phones in the network. This is based on the addressing systems. Okay, this is the things and comes under this data link layers. This is physical addressings. Okay, MAC address. So to know this MAC address is very important to transmit the data in the network. Okay, we'll done up to this physical address. Then next class we'll continue in the error control of the data link layer.